नमस्ते। ओम गम गणपतये नमः। इंद्रियों से उनके विषय बलवान हैं, क्योंकि वे बलात् इंद्रियों को अपनी ओर आकर्षित कर लेते हैं। उन विषयों से मन बलवान है, क्योंकि वह इंद्रियों को उनसे हटाने में समर्थ है। मन से बुद्धि बलवान है, क्योंकि वह मन को वश में रख सकती है। और बुद्धि से आत्मा बलवान माना गया है, क्योंकि वह बुद्धि को सम बनाकर स्वाधीन कर सकता है। महाभारत गीता प्रेस भाग 5 शांति पर्वणि मोक्ष धर्म पर्वणि शुकानुप्रश्ने अष्टचत्वारिंशदधिक द्विशततमोऽध्यायः। नमस्ते। Om Gam Ganapataye Namaha. Are there enough hours in the day to get all done? You are not alone. Meet Chiku, a high school student juggling classes, homework, and independent study. With exams looming, he is stressed, but math can help. Linear programming, developed during World War II to optimize military resource allocation, is a powerful tool that can help solve Chiku's time management challenge. In this video, we will explore how it can help Chiku and you make the most of your time. By the end, you learn how to balance school, assignments, and self study to maximize learning outcomes. Here's the plan. First, we'll explain what linear programming is and why it's useful. Then we'll define Chiku's specific problem. Next, we'll set up the mathematical model, variables, objective function, and constraints. After that, we'll solve it using Python. Finally, we'll discuss interpreting the results and adapting the strategy over time. We will use infographics to make concepts clear. Whether you are a student, parent, or curious about optimization, this video is for you. Let's begin. What is linear programming? Well, linear programming is a mathematical method to find the best outcome in a situation with constraints. Developed during World War II to optimize military operations, it's now used across industries, from logistics to finance, to maximize efficiency and minimize costs. The linear part means relationships among variables are linear, forming straight lines when graphed. For Chiku, it means optimizing time for school, assignments, and self study. Simple problems can be solved graphically, while complex ones, with many variables, rely on algorithms like the simplex method. Chiku has three activities: attending school, doing assignments, and self studying. Each contributes differently to his learning effectiveness. With limits on total time and minimum requirements, we'll define an objective function to maximize effectiveness while meeting these constraints. Don't worry, if this sounds complex, we'll break it down. The key components are variables, what we control, like hours per activity, the objective function, what we want to maximize, and constraints, the limits we work within. By the end, you will see how this applies to Chiku's schedule and how you can use it too. Let's define Chiku's problem. Let's dive into Chiku's challenge. As a high school student, Chiku juggles three activities: attending school, completing assignments, and self studying. Each demands time, but Chiku only has 40 hours per week after sleep, meals, and essentials. Linear programming, praised for its ability to solve complex scheduling problems in industries like airlines, can help. Chiku's constraints are: school requires 20 hours, assignments need at least 5 hours, and self study needs at least 5 hours to boost understanding. Hello. Oh, yay, yay, yay. So we have total time 40 hours, minimum school time 20 hours, minimum assignments 5 hours, minimum self study 5 hours. Chiku's goal is to maximize learning effectiveness. We'll estimate effectiveness. Each hour of school gives 1 unit, assignments 2 units, and self study 3 units, based on their impact on grades and understanding. These are starting guesses. Chiku can tweak them later. Why use linear programming? It's transformed industries by optimizing resources, and for Chiku, it replaces guesswork with a structured plan. Next, we'll model this mathematically to find the best time split. Setting up the model. Now, let's turn Chiku's problem into math. Linear programming strength lies in its ability to model complex systems with simple equations. We define variables: x1 for school hours, x2 for assignments, and x3 for self study. Chiku wants to maximize effectiveness, defined as z equals 1.x1 plus 2.x2 plus 3.x3. School gives 1 unit per hour, assignments 2, and self study 3. Constraints are total time x1 plus x2 plus x3 smaller than or equal to 40. Minimum school x1 greater than equal to 20. Minimum assignments x2 greater than equal to 5. Minimum self-study x3 greater than equal to 5. Time can't be negative, but minimums cover that. So we maximize z equals x1 plus 2x2 plus 3x3 subject to these limits. This setup mirrors how linear programming optimizes supply chains or energy grids. For Chiku, it's about balancing school demands with study goals. We expect self study to get priority due to its high effectiveness, 3 units. Next, we'll solve this using Python in a Jupyter notebook. Solving with Python and Matplotlib. Let's help Chiku solve this using Python's pulp and Matplotlib in a Jupyter notebook. Pulp tackles linear programming and Matplotlib visualizes results. Let's install them. Pip install pulp matplotlib. Use %matplotlib space inline to show plots below the cell, Jupyter Notebook cell. Create the problem. Prob equals pulp.lp problem with first argument as student time allocation string and the second argument as pulp.lp maximize. Define variables x1 school, x2 assignments, x3 self-study. Set the objective prob plus equals 1 star x1 plus 2 star x2 plus 3 star x3. Add constraints. X1 plus x2 plus x3 smaller than equal to 40, x1 greater than equal to 20, x2 greater than equal to 5, x3 greater than equal to 5. Run prob.solve. Results are x1 equals 20, x2 equals 5, x3 equals 15. As 20 plus 5 plus 15 equals 40, effectiveness is 1 into 20 plus 2 into 5 plus 3 into 15 equals 75. Matplotlib creates three plots: a bar plot, 20 hours school, 5 assignments, 15 self-study; a pie chart, 50%, 12.5%, 37.5%, respectively, and an effectiveness plot, 20, 10, 45 units. These show why self-study is prioritized, a technique used in fields like finance to optimize portfolios. Compare. If x2 equals 10, x3 equals 10, effectiveness is 70, less optimal. Chiku's plan: 20 hours school, 5 assignments, 15 self-study. These visuals make it clear. Don't worry, we will be sharing the code uh, below the video. What does this mean for Chiku? The model suggests 20 hours school, 5 hours assignments, and 15 hours of self study per week, maximizing effectiveness at 75 units. Linear programming's computational efficiency, like the simplex algorithm, ensures quick solutions even for complex problems. Chiku meets minimums 25-5 and prioritizes self study due to its high effectiveness, 3 units. But life isn't static. If assignments need 10 hours, Chiku updates the constraints x2 greater than equal to 10. The new solution x1 equals 20, x2 equals 10, and x3 equals 10 with effectiveness 1 multiplied by 20 plus 2 multiplied by 10 plus 3 multiplied by 10 equals 70. This trade off shows less self study lowers the score. Chiku could adjust by making assignments more efficient or blending self study with them. The bar and pie charts from our Python code help Chiku visualize this balance. Just as businesses use linear programming to optimize production, flexibility is key. Chiku can test this plan and tweak it based on his grades or understanding. Time management is a journey, not a one time fix. Chiku adopts an agile approach, like software teams, using linear programming to optimize sprints. Each week, he plans, acts, reviews, and adjusts. After trying 20-hour school, 5 assignments, and 15 self study, Chiku checks. Did assignments get done? Was self study effective? How were his grades? If self study's impact was lower, he might reduce its coefficient from 3 to 2. If assignments took 10 hours, he updates x2 greater than equals 10. Rerunning the Python code with matplotlib updates the bar and pie charts showing a new plan. This iterative process, rooted in linear programming's ability to refine solutions, helps Chiku adapt as workloads change. You can try this too. Estimate your effectiveness coefficients, set minimums, solve in a Jupyter notebook, and adjust weekly. It's a practical way to master time, just as linear programming optimizes global supply chains. Flexibility is key. What works one week might not the next. Thanks for watching. If you enjoyed this dive into linear programming, like and subscribe for more math and optimization tips. Good luck, Chiku, and you on your time management journey. Thank you.